Hello, I am James Keene, talking about quantum gravity mechanisms. My outline includes 1. A motion law acts to aggregate or compact energy quanta in objects from nucleon to astronomical size. 2. A repulsive effect of outward IR heat radiation momentum may oppose to some extent the motion law aggregating effect. I give examples of the motion law and centrifugal IR radiation effects. Temperature-dependent Casimir force experiment using the Binary Mechanics Lab simulator software. Then we go to lunar laser ranging study showing Earth-Moon gravity increased by higher lunar surface temperature facing Earth. Then we have GRACE satellite data analyzed confirming gravity surface temperature dependence. And we talk about LIGO gravitational waves, also confirmed another result, light speed dependence on vacuum energy density, not general relativity. Thus far, all known gravitational effects may be exclusively accounted for by quantum level mechanisms. Several consequences of the postulates of binary mechanics may be summarized in a basic physics law of motion, that objects tend to move in the direction of higher bit density. This idea is illustrated above in one spatial dimension. This working hypothesis is applicable for objects ranging from elementary particles to astronomical objects, such as planets to galaxies. Assume that energy quanta, one-state bits, have equal probability of moving in either direction along the x-axis. Recall that detectable particles are thought to contain 2 or more quanta in their defining spot locations. Therefore, quanta moving to the higher density region to the right above have a greater chance of forming particles compared to those moving to the lower density volume to the left. On the surface of an object, the black circle with greater quanta density than the surrounding volume, the red arrow here, it directs attention to small objects' particles on the surface which would tend to move inward. This effect occurs at every point on the surface of the greater density object. At temperature greater than 0 Kelvin, infrared radiation directed outward toward the object's surface carries momentum, pushing material toward the surface, shown by the arrows in every place here. A repulsive effect opposing the inward motion law aggregation. Thus, balance between inward motion law aggregation and outward IR radiation momentum determines, to a large extent, object size. IR radiation from a heated object delivers momentum away from the heated object to other objects, causing a repulsive effect. Dmitriev showed that heating an object reduced its measured weight in milligrams. Here is the period of heating. The heating turned off, and the effect is decreasing. The decrease in mass. 2 mechanisms balanced in Earth inner layers, perhaps. 1. Motion law aggregates, compacts each layer with respect to material in surrounding lower density volume. 2. The radiation from higher temperature inner layer delivers momentum to lower temperature material in surrounding lower density layer. The layer formation reflects opposing effects of centripetal motion law, attraction, and repulsion from momentum of the outward radiation. Here's an example in 2 dimensions with altitude equal to quanta density. With the motion law, inertial motion follows geodesic paths, the red lines and arrows here, toward greater quanta density without need to postulate space-time curvature and to believe in miracles. With general relativity, religion is mixed with science, with the miracle of infinite number of infinitely small, quote, inertial motion guidance devices, close quote, in any arbitrary volume. General relativity requires belief in miracles. One does not simply postulate an infinite number of infinitely small things in any arbitrary volume without calling it a miracle. General relativity requires an infinitely small inertial motion guidance device at every point in curved space-time, a miracle unacceptable even in theology schools. Let's think about a 0 Kelvin or close to 0 Kelvin object where there's no or almost no IR radiation coming from it. Even in that case, that object will move toward another object at greater than 0 Kelvin, emitting IR radiation. Why? Because the surface closest to the radiating object will have a higher bit density than other surfaces. Therefore, the arrow shows the direction of motion due to the motion law. Let's consider a case where both objects are emitting radiation, such as Earth and Moon. And here we have the case again, where between the two objects is where the bit density is greatest. And the motion law states that objects tend to move toward greater bit density. In particular, for the object on the left, we see it has a greater density here than away from the other object. The same here on this side. Therefore, this object will move to the left. Here we show both spheres at temperature greater than 0 Kelvin again, the two objects with greater quanta density than their surrounding volumes. If object temperature is greater than 0 Kelvin, radiated thermal energy will increase quanta density most at the nearest surface of the other objects. Therefore, each object will tend to move toward the other. This motion will be opposed by the momentum of incoming quanta. Quanta from here will oppose the rightward motion of this object. Now let's move to the Casimir plate experiment display at Binary Mechanics Lab Simulator TIC 24. Here there were originally 2 plates, and after 24 ticks we see that there are a number of quanta emanating from these plates, and here's the distribution shown in a histogram. A result detail is reducing distance between the two objects suggests a gravity-like effect. Here the distance is being reduced over time. One such effect is the slope increases about tick 10, here, slope increase, and tick 32, the slope increase compared to here, indicating increased acceleration over time. At tick 45, decreasing slope suggests increasing IR radiation repulsion. Here we show the full 1,000 ticks. At the right, a stable distance between the two bodies was observed. Oscillations reflect quantum motion in proton bit cycle. Around tick 400, the final phase of the two-body distance decrease appears to overshoot the final stable distance here. In 2011, I wanted to shatter space-time energy quantization in binary mechanics with an intentionally outrageous, outlandish hypothesis based upon the motion law. And here's what we have. Rather than shattering it, it confirmed binary mechanics and called into question general relativity. Quantitatively large effects of lunar surface temperature on apparent gravitational force measured by lunar laser ranging and lunar perigee may challenge widely accepted theories of gravity. LLR data grouped by days from full moon shows the moon is about 5% closer to Earth at full moon compared to 8 days before or after. In a second related result, moon perigees were least distant in days closer to full moon. Moon phase was used as proxy independent variable for lunar surface temperature. These results support the prediction by binary mechanics that gravitational force increases with object surface temperature. From days 0 to 6, the shortest distances occurred, while longer values were seen in days 7 to 11 from full moon. Perhaps of special interest is the almost linear trend in offsets of LLR distance from calculated perigee from day 2 to day 11. Almost linear. Indeed, these days analyze the product moment correlation between day and LLR distance minus perigee is 0.97. That is, for days 2 to 11 from full moon, time from full moon accounted for 94%, that's the correlation squared, of the variance of LLR distance minus calculated perigee values. This study aimed to test the hypothesis predicted by binary mechanics that observed gravitational force increases with increased object surface temperature. Moon phase was used as an indication of the independent variable, temperature on the lunar surface facing Earth, with highest temperature associated with full moon, of course. LLR data was used to operationally define the dependent variable, Earth-Moon gravitational force, assumed to be inversely related to lunar distance. In short, greater lunar surface temperature in the direction of Earth was associated with motion reducing lunar distance. Lunar phases reflect changes in Sun-Moon Earth angle. At any time, about half of the lunar surface is illuminated and warmed by the sun, while the other side of the moon is dark and becomes cooler. Hence, the volume average temperature of the moon may be essentially constant over the days analyzed before or after full moon. Therefore, the effect discovered in this report appears to depend on a surface temperature differential comparing near and far sides of the moon as lunar phase changes. Namely, when this temperature difference increases on days closer to full moon, Earth-Moon distance decreases. The vector from the coolest to the warmest surface area appears to approximate the direction of this motion component. Conventional treatment of thermal energy as a gravitational mass equivalent fails to account for the reported results. In the BM motion law, objects tend to move in the direction of greater quanta density. Observed gravitational forces are simply a specific instance of this general quantum principle.